Welcome students. Today we will learn a very important chapter of circuit theory that is called Laplace Transform. What is Laplace Transform? This is the basic formula of Laplace Transform. Laplace of ft is equal to fs 0 to infinity ft to the power minus st. So time domain to s domain. S domain is known as Laplacian domain. Laplacian domain. So, time domain to frequency domain conversion happens in Fourier transform. Time domain to S domain transform happens in Laplace transform. What is S? S means sigma plus j omega. Sigma is a real quantity, real part of a function, and omega, j omega is the imaginary part. Now, this is the unit circle, this is sigma is the real, this is j omega is the imaginary. Sigma is the real, and j omega is the imaginary. Now, this is the unit circle, plus 1 amplitude, this is minus 1 amplitude. So, a signal exists between real plane and imaginary plane that can be expressed in the form of Laplace transformation. But if you want to express a signal by using Fourier transformation, what is Fourier transformation? F omega is equal to 0 to infinity ft e to the power minus j omega t dt. This is Fourier transformation. And inverse Fourier is Fourier is 1 by 2 pi integration 0 to infinity f of omega e to the power j omega t d omega is equal to your ft. So time domain to frequency we have to convert time domain to frequency domain. This is frequency domain, this signal is given in time domain. Suppose sine of omega t. Signal is given in time domain. In time domain, you will have to convert it into frequency domain. Suppose sine of t is given to you in time domain. So you have to express this in the form of frequency domain. So it is known as Fourier transform. But if you want to express time domain to Laplacian domain, that is S domain, so here the signal, in case of Fourier transform, signal is confined in only imaginary axis. We have taken only imaginary part. This is e to the power minus j omega t. J omega is the imaginary part of the signal. We have taken only the imaginary part of the signal, but in case of Laplacian domain, we have taken both the imaginary, we have considered both the imaginary and the real part of the signal. Now, in your circuit theory, you are studying only circuit theory. So, Laplace transform you are applying in circuit theory. So, you will have to confine in Laplace transform only. We don't need to bother about the Fourier transform. So, in circuit theory, whenever you are doing some work in circuit theory, you will have to use some functions. You have to know some functions, applications, how to calculate the Laplace transformation of those very common functions, very common trigonometric functions that are used in circuit theory. Very common trigonometric functions that are used in circuit theory are sine of omega t. They are sine of omega t, cos of omega t, e to the power minus at, sine omega t, e to the power minus at, cos omega t. These four functions are we use rapidly in circuit theory. These four functions, they are very common functions. So today we will learn the Laplace transformation of these four common functions. Apart from that, we will learn Laplace transformation of the very common signals of circuit theory. Very common type of signals of circuit theory. Very common type of signals that are used in circuit theory. First, sine of omega t ut. So sine of omega t means e to the power j omega t minus e to the power minus j omega t by 2j sine into e to the power minus st dt. We have taken t common from both sides. it will be after multiplying both the e to the power j omega t and e to the power minus j omega t with e to the power minus st, it will become e to the power minus s minus j omega t minus e to the power minus s of s plus j omega t. So we have got two functions for Laplace transformation. Our limit is 0 to infinity. So after doing Laplace integration is by using basic Laplace transformation formula, fs equal to 0 to integration 0 to infinity ft to the power minus st dt. So it will be 1 by s minus j omega and 1 by s plus j omega, because e to the power minus infinity is 0 and e to the power 0 is equal to 1. If we put here e to the power minus infinity, it is 0. So my 0 minus e to the power 0 minus e to the power 0 divided by s minus j omega. So it will be 1 by s minus j omega. Here also 0 minus within bracket minus 1 by s plus j omega. So minus it will be plus. So it will be 1 minus is there. Minus is there here one minus is there, so 1 by s plus j omega. Now do the calculation, perform the calculation. It will be omega by s square plus omega square. This is a plus b, a minus. This is a minus b, a plus b. So it formula is a square minus b square. So your final result is omega by s square plus omega square. Now let's perform the cos of omega t ut. So it is 0 to infinity cos of omega t into e to the power minus st. That means e to the power j omega t plus e to the power minus j omega t by 2 into e to the power minus st dt. So t is common in both the cases. E to the power minus s minus j omega t plus e to the power minus s plus j omega t dt divided by 2. So the after doing integration, it is e to the power minus s minus of e to the power minus s minus j omega t divided by s minus j omega plus minus within bracket minus e to the power minus s plus j omega t by s plus j omega. So limit is 0 to infinity in all the cases. So e to the power minus infinity is 0. This part, first part will be 0 minus e to the power 0 minus of e to the power 0 divided by s minus j omega. So minus it will be plus. So 1 by s minus j omega. Here also 0 minus of 0 minus within bracket minus of e to the power 0 divided by 1 plus e to the power 0 divided by s plus j omega. So it will be 1 by s plus j omega, because minus is plus. Okay, minus is plus. So it will be 1 by s plus j omega. So final result divided into half. In all the cases, half is multiplied in all the cases, because cos of omega t means e to the power j omega t plus e to the power minus j omega t divided by 2. So it is final result is s by s square plus omega square. Shortly after the next video, we will learn more complex integration, that is e to the power minus at sine of omega t e to the power minus st. Now the question is what is ut? I have written ut here. Ut means unit step function. How to calculate the Laplace transform of unit step function, unit ramp function, and delta function. That also we will learn in this class. Shortly after this video, next video, I will teach you how to calculate Laplace transformation of these three functions. Shortly after the next video, I will teach you more complex integration, that is e to the power minus at sine omega t and e to the power minus at cos omega t.